So I've cleaned the cluster up a bit since the last time around. So now there's only like the admin or the management containers running on the 3 nodes again. Well, this time around, we're going to schedule containers against the cluster with specific RAM requirements or RAM reservations. So this is the plan. These are our 3 cluster nodes. And you know what? I really wasn't thinking far ahead when I planned the cluster, because all 3 are T2 micro instances in AWS. So they've all got a paltry 1 gig of RAM. I don't know, the demo might have been a bit better if one of them was bigger or something, but never mind, they're all the same size, they've all got 1 gig. So what we'll do is, we'll schedule a couple of 900 meg containers. Now what this means, right, is when we schedule the container, we ask it to reserve 900 meg of the RAM available on the host. Well, as we're scheduling 2, they should get balanced over 2 nodes. Then we'll kick off a bunch of maybe 150 meg ones. Now here's the crux. There'll obviously be no space here on these 2, meaning the rest of them will have to get scheduled over here on node 3. That is, until that one fills up, and when it does, well, you know what, we'll see what happens then. Right, on our Docker client again, and in fact, I think we can see memory from Docker info. Yeah, so look, there we go, a gig on each node. And if we look closely, currently, none of that is reserved. That's because we haven't started any containers yet with specific RAM reservations. And down at the bottom here, we can see the cumulative memory for the entire cluster at 3 gig. And you know what? The CPU info as well, because what we're going to do here with memory can totally be done with CPU as well. Anyway, to start a container requesting 900 meg, we just add the -m flag here and then say 900M. That should do it. Okay, same again. Right, so that's our first 2 containers scheduled. Let's see how things look now. Okay, so node 1 and node 3. And let's see how this looks now. Right, see how we can see the reserved memory showing up. And yeah, okay, that's fine when we've got 3 nodes. Somewhat trickier though when it's like 50, 100 or even more. But let's get back and schedule some more containers. And we'll tweak this down to 150. Okay, come on, we'll just keep cracking them out until something gives. Right, no resources available. Sounds like we've pushed our cluster to the max, yeah? Used all of its available RAM. And a Docker info. Right, a proper imbalance we can see now. 4, then 9, and then 4 again. And you know what? Despite the spread strategy. And see how memory's updated? So what have we seen here? Well, we've seen how reserving CPU or RAM requirements for our containers can override the mechanics of the scheduling strategy. Well, sort of, okay? It cuts out certain nodes that can't provide the required resources, and then it lets the scheduling strategy operate over the remaining nodes that can. Okay, next, affinity filters.